These are the same kind of plastic shrinkage crackings. And if you can see there, if you use GGBFS, your tendency of plastic shrinkage cracking will be very low. If you use fly ash along with the reduction of water cement ratio, you will have a very high tendency. For the normal concrete, it may occur, but the tendency will be low. Now, how to repair a concrete pavement? It is very difficult to repair a concrete. In the context of concrete pavement, we always say it is better, prevention is better than cure. Because if something happens to concrete, you have to break it, remove it, and fill the patch with the fresh concrete. So breaking and removing the concrete, even if it is a very low grade concrete, very low strength concrete, it is a hell of a job. It is a very tedious and very difficult job. So it is better that all these type of distresses do not appear. Take due care during the construction removal. Width of that portion should also be minimum 1.5 meter. If it is less than 1.5 meter, then it will not behave like a slab. It will behave more like a beam, and different kind of stresses may appear in that repaired area. So you have to remove, you have to cut the entire concrete, then you break it, remove the concrete. After you remove the concrete, you will have two full depth joints. So you have to insert the dowel bar, first create the dowel holes, then clean them out of dust should be removed, and then neat epoxy is inserted into the dowel holes, and then dowel bars are fixed. You can place the sheathing caps or plastic caps over the dowel bars, and if subbase is also damaged, you repair the subbase also, and then fill it with fresh concrete, compact it, texture it, and use some curing compounds so that plastic shrinkage cracking can be avoided. Sometimes if a slab has more than one full depth cracks, suppose it has two full depth cracks, so whole slab will be divided into three parts. So entire slab has to be removed. Code says that we do not accept more than one crack in a slab. If it has got multiple cracks, you have to remove it up to the full depth, and it is the same procedure. But whenever you remove the full depth slab, entire slab, it is not the slab, but some extra portion also. Whatever dowel bars assembly is existing on both the sides, that assembly has to be removed also, because during the removal and breaking of the concrete, all the dowel bars may become loose and they will not be effective. So the dowel bars on both the sides of the joint has to be removed, and then entire patch has to be filled up with the fresh concrete, compacted and finished in the same way. This is another way of cracking. If you do not do the socketing at proper time, then you will observe that full width and full depth transverse crack will be observing at an interval of 10, 12 or 15 meters. Those cracks are called working cracks, because those are not structural cracks, though it is full depth and full width, but it has not because of the structural failure of the concrete. It is occurring because you could not socket the joint at proper time with proper depth. So those joints actually are working as a joint. They are accommodating the expansion and contraction of the slab. So those cracks may be treated like a joint. And what we do at the joint? We create a groove at the joint and seal them so that water and sand and silt do not enter into the joint. Same thing we can do here. If it is a working crack, then just prepare a groove along the contour of the crack and then fill it with any polysulfide or silicone sealant, whatever we use for the joints normally. This is cross stitching. Cross stitching is always used for longitudinal crack. Any longitudinal crack, before it opens up too much, you have to fix it. You have to cross stitch it. Cross stitching will not prevent further occurring of the crack. What it will do, it will keep the longitudinal crack just intact, just in a very close form. It will not allow it to widen up further. So for that you have to do cross stitching. Cross stitching is never done for a transverse crack, because transverse crack movement is allowed, but we do not allow movement at longitudinal cracking. That's why longitudinal cracking we go for cross stitching. In cross stitching we make inclined holes from alternate sides, and then in those drill holes dowels are inserted, and then annular space is filled with epoxies and mortar. On the top surface we will see only circles like this. We have a longitudinal cracking which has been cross stitched. You can see only circles at the surface. Otherwise, there is dowels are existing inside all these holes, drilled holes. So cross stitching will not allow the longitudinal joint, longitudinal crack to open up further. Plastic shrinkage cracking, you have to take care. Just after the finishing of the concrete, you must use curing compound. Second, you can cover your surface with plastic sheets also. And third, if you have very high tendency of plastic shrinkage cracking, then keep some jute bags ready in moist condition. Water should not be draining out of them. They should be just in moist condition. And after texturing the surface, you cover the entire surface of the concrete gently, because concrete is still in green state. If you will throw the bags over the recently just completed concrete surface, all texture will go. So you have to put all jute bags very gently on the textured surface.
Sir, 2 minutes.
It's okay, sir. It's over now. So plastic shrinkage cracking is preventable. First, see your mix. It should not have a very low water cement ratio. Normally, we do the concrete PQC at a 0.38 and 0.4 water cement ratio. That is the ideal, that is the best water cement ratio. Do not come down to a water cement ratio of 0.32 or 0.33 just for the saving of the cement. You can save the cement if you use the, again I say, you can save the cement if you use the slag in your concrete pavement mixes. So see what is the mix. It should not have very low water cement ratio, and then cover the surface with plastic sheathing and moist jute bags. If you are not able to do that and plastic shrinkage cracking has occurred, then they will remain there throughout the entire life of the pavement. What we can do, later on we can fill them with neat epoxy. First, clean the crack with a wire brush so that every dust comes out, and then you can have a water-like thin epoxy that can be filled into the cracks. And after the cracks, you can spray some coarse sand over those epoxy so that it is bonded with the epoxy, and you will not have a very shining or very smooth surface which is prone to the skidding of the vehicles. This is the last. If your concrete is very poor, then after opening the traffic, you will see a very rough surface. Total texture from the surface has been removed. It is an indication that your concrete is not of M40 grade. And definitely it is less than M25 grade, because concrete up to M25 or M30 grade may have some traffic without removing the texturing for some time. But whatever we suggest for the concrete pavement for national highways or state highways, it should not be less than M40. If surface has been abraded, it is a clear indication that your concrete is of poor quality, and there is no other way. Then you have to go for bituminous overlay, either mastic asphalt or BC, or again you have to go for bonded concrete overlay. So always use a concrete of proper mix. So I repeat, pay attention to your concrete mix, take care of plastic shrinkage cracking just after 2-3 hours after the placement, and make socket joints after 8-10 hours to 24 hours. You complete all these and take care of uniformity of the support. If you take all these care during construction, I can guarantee that whatever pavement has been designed for 30 years, its actual service life will be more than 30 years, and examples have been there. So thank you very much.
Okay.
And thank you ICW for inviting me for this lecture also. Thank you very much, sir.
Thank you, sir. It has been always knowledgeable when you talk about concrete rehabilitation, especially the pavement. There are a couple of people who are rising. Vivek has got a question for you, and Dr. Ramchandra. Sir, you will be the second one because you have got a duty to perform.
Firstly, I would like to congratulate you for in-depth presentation, because this type of presentation can be given by a person who has done the things on the ground level.
Thank you, sir. Thank you, sir.
So, my one observation, in one of your slides, you have shown that the plastic shrinkage cracks can be high if you are using PCE-based admixture.
Right, sir.
Am I correct somewhere? Can you just go on to that slide and clarify the matter? 7th or 8th side in somewhere.
That is plastic
I might
shrinkage
have
crack.
misunderstood also, but
I'm coming. So what is your question, sir?
A possibility of development of plastic. Yeah, here
Yeah.
it is. Tendency of development of the crack, you say very high.
Yeah.
When PQC with fly ash and then.
What do
and
you
mix
normal
super
mix have
plasticizers
400
PC.
kg cement.
Huh?
Normal mix is 400 kg cement. 0.38 water cement ratio.
Okay.
When you replace cement with fly ash, so you come down to 320 kg cement plus 80 kg fly ash. But to achieve the same 7 days or 28 days strength, you have to lower down the water cement ratio. So you come to 0.3 to 0.34, and you have to use PCE based super plasticizer, because only PCE based can give you workability at that lower water cement ratio. And if water is very less in your mix, your tendency of plastic shrinkage cracking will be very high, because the rate of bleeding will be very low and rate of evaporation will be too high. In case of GGBFS, even if you replace 40% of the cement by GGBFS, that means 240 kg cement, 160 GGBFS, you can keep water cement ratio as it is 0.38 without any downfall in your 28 days strength. And you can use the normal naphthalene based super plasticizer. Even you can use PC base also, but there is no need to lower down the water cement ratio.
What I wanted to say that in all these three cases, you can always use lower grade PCE without any cracking.
You can use any plastic, any
It has
super
got nothing
plasticizer.
to do with the base of the plasticizer.
No.
It has
You
got
can
something
use
to do with the mix.
You can use any plasticizer for workability.
Last Friday, around the same time, me and Vinod had a same discussion in
Yeah.
Delhi. Okay, what
You can use any plasticizer, but keep water cement ratio 0.38.
Okay, what he means is just to reduce cement, don't go into a high-end PCE based admixture. Am I right, sir?
Right, sir.
Just to reduce cement, don't go into a high-end. That would lead to more cracks than going with SNF and going, or a combination of SMS and mid PC.
Water cement ratio is critical. Whatever be the kind of super plasticizer, it should not be less than 0.37 or 0.38.
Dr. Ramchandra, your question, and after that, you need to present him with a bouquet.
Dr. Vinod, I have a very short question. The last slide you said that if the quality of concrete is poor, then the only way ahead is to go in for another layer.
Yes, sir.
Now, what should be the thickness of this layer? Because it is only a correction layer.
Right, sir. If you are going for a bonded overlay, then I would recommend that it should not be less than 100 mm. If it is bonded overlay.
Yeah.
If it is unbonded, then it has to be designed like
Normal,
a new normal concrete. Then it may be around 250 or 300 mm. But for bonded overlay, and we are preparing a code also. It is under preparation these days, and within next 1 or 2 months, you may have a bonded overlay code also. In that, it has been mentioned that minimum should be 100 mm. In bonding conditions, M40, grade is same. Grade should not be
Ramchandra,
poor,
can you
otherwise
come on
same
stage
thing
to
will
present
appear
him with a
again.
bouquet? We have the governing council meeting going on. Many of the governing council members are texting me. We will restrict the question. Dr. Binod Kumar will be available for some time. We can have a one-to-one discussion.
With your permission, one last question. The question is, you said, say 400 kg cement, 0.4 water cement ratio, if it is OPC.
Right, sir.
And in other case, we replace OPC with your 70% GGBS.
Yes, sir.
In which case you anticipate more plastic shrinkage?
No, I will not say 70%. I will recommend 40%.
GGBS is finer than your cement.
No, I would say around 40%. Not go, do not go at 70%. Most optimum is 70%. At that, and with water cement ratio of 0.4, you will have lesser tendency of plastic shrinkage cracking.
My point is, if you go for more finer materials, there are more chances of plastic shrinkage crack.
Maybe, but you may not get the strength also. I will not say that 70% will give you the strength parameter also. But with 30-40% GGBFS, very conveniently, you can satisfy the requirement of the strength also, and your plastic shrinkage cracking will also be under the control because enough water is available. But what my intention was, do not lower down the water cement ratio just to save the cements. Fly ash will not work. GGBFS can better work than fly ash.
limit of GBS is 50% as per IRC.
Yeah, as far as.
Dr. Ramchandra is Functional Head Technical Services, Ultratech Cement. Thank you, Binod Kumar. We will be shortly adopting you as a Bangalorean. We now have Engineer V.R. Kulkarni talking to us about concrete sustainability, current status, challenges, and a welcome initiative. V.R. Kulkarni is past president of Indian Concrete Institute. He has been one of the leading people who brought in RMCMA. Sir, you have 20 minutes.
I think I'm going to present a sustainability scenario. I think we have been talking about it right from the beginning of this seminar. Dr. Chatterjee talked about it, and many people know about it. We have been reading about it. We have been experiencing about it. But even at the cost of repetition, I would like to repeat it and bring it to the notice of all engineering community. A very grim scenario. What I would say is that we are facing a global warming. These are the data obtained from interpanel governmental body, which is consisting of all nations, and most of the scientists have agreed to that these irreversible changes have occurred already, and we are facing literally a very serious situation as far as global warming is concerned. Some of the data shows that the average increase has been 2 ppm for the CO2 and other greenhouse gases. A very serious situation. The why it has happened, of course, we can always blame the population rise, that it has been, our Mother Earth is unable to sustain such a large population rise today. Even India, we are experiencing a very large population rise. Then, to sustain such a large population, the industry wheel must go on. And the urbanization and the industrialization has been happening. We are experiencing a reversing trend here as far as urban scenario is concerned. And then, this has also happened as far as the levels of the sea has risen. The water of the sea itself is unable to absorb CO2. Now it has become acidic. And all this has resulted in a situation where we are also in India experiencing a similar scenario. We have been expanding our urban centers. We were just 25 cities of million plus cities. In 2011, we have changed to 53, so almost doubled. And all this has simultaneously happening, a lot of development, including the use of concrete, which is essential, I would not deny it. But the question is whether such development is sustainable. We have large projects going on at the moment, and also we are experiencing simultaneously extreme events. 2013 we had floods in Uttarakhand. We have recently floods in Kerala. We have drought in some part of the country, and we have a cyclone in some part of the country. So extreme events are everybody has agreed, all scientists agree that it is because of the rise in the CO2 emission and of course because of the rise in temperature. And as far as our country is concerned, we can't escape this, that in spite of all hype about the renewable power, coal has still remained as a main source of our energy, and because of coal and because of the other effect, we are gone to number 3 in emitting CO2 emission today in the world. And our scientists are trying to, avoid these questions. There were some studies which has shown that after all, our average emission is less than the world average. But the fact remains that we are amongst the top 5 as far as CO2 emission is concerned. We have to take this situation seriously, and fortunately, the government is aware about it. Our government has pledged in Paris Convention that it will reduce this greenhouse gas emission by 35%. It will also reduce the 40% electric power consumption will be replaced by renewable power. A lot of emphasis is being given to that, and also we will increase our forest cover. As far as industry is concerned, our own industry, we are the largest users of materials, water, land and energy. So we have to be more particular about the CO2 emission and the greenhouse gas emission. And concrete being the largest man-made material, concrete has more responsibility as far as the total CO2 emission is concerned. At the same time, we must also understand that concrete is a eco-friendly material. That why I say eco-friendly, it is because it is requiring least energy per unit of consumption. If you compare different materials, you see that the energy consumption required for the production of 1 unit of concrete is much less than the other material. It yields least byproduct in its production. On the contrary, it has a capacity to absorb the byproducts of the other industry, like the fly ash and GGBS we have been talking about. So in the process, concrete has been there with us as the largest man-made material, and it is there is no other material which can replace it, and people know about it. But the kind of volumes that we are creating, it has become essential for us to make the concrete more sustainable. So how do we make the concrete sustainable? We go to the concrete guru, Professor P.K. Mehta, who has given us the lead and who says that we can make concrete more sustainable by using 3 simple tools. One is use less concrete. So the structural designer and the architect should use less and less of concrete by designing it using high-strength concrete, which is today available, high-performance concrete, which is available, ultra-high-performance concrete, which is available. So these are the tools. Use less cement in your concrete, more of fly ash and GGBS, and use less clinker, so the clinker factor has to be reduced. So the first question that arises, and I have been talking about it since I was the president, that whether our country has the resources, sufficient resources, to produce the kind of development that we are postulating in our country, as far as the concrete is concerned. And Indian cement industry is experiencing a growth today, and it will go. Today we are producing around 300 million ton, and we have a capacity of about 450 million ton, and we are expected to grow at around 7 to 8%. Good for the industry, good for the development, but at the same time, we should see whether we have sufficient resources to produce. For example, take limestone. Do we have sufficient limestone? The answer is no. The answer says that we have limestone reserves which can be ecologically extracted. You know, they can last us for another 35 to 40 years. This is the report from the Planning Commission. Coarse aggregate, leads are increasing. Everybody is, experiencing that the aggregate that we are, bringing to major urban centers, the leads are increasing because the aggregates near about has exhausted. River sand has vanished, and rightly so, because it has created havoc as far as the ecology of the river is concerned. Our rivers have become really ecologically dangerous. And crushed sand, we find that there is still a resistance among some quarters. Of course, there are many people who have started accepting it, but still many people are opposing the use of crushed sand. Water, we are still facing drought situation in many parts of the country, and we have less water per capita, so water is also, availability is becoming less. But at the same time, we have lot of industrial waste, heaps and heaps, mountains and mountains created over previous decades. So we can use it, we can use it in a better manner. Now let us see what's happening to the green building movement. Fortunately for us, the green building movement is increasing, and as of now, the around 5 billion square feet has been already created, green building, and they are planning to go to 10 billion, which is a very good development. But the people who are leading is the Green Product Services Council, GPSC, of the Confederation of Indian Industry, and they have produced a number of green products. And recently, we have approached them and asked them to produce a similar kind of certification and structure for the concrete as such. And this is a joint effort by the Ready Mix Concrete Manufacturers Association, CII, and the QCI, and this initiative is now supported by the International Finance Commission. So what is the objective is to facilitate RMC producers to adopt green measures, more and more green measures, facilitate and enhance green performance of the RMC product, reduce greenhouse gas emissions, and they have set a target to themselves that they will reduce this greenhouse gas emission by 150,000 tons per annum if people start adopting the green certification for concrete. Already there are many people who have started, adopting this thing. And I would just try to make a broad framework under which we can call, because till now there was a misconception that you use some amount of fly ash, some amount of GGBS, and then you become green. Okay. Now that is not the concept. The concept is derived from the Concrete Sustainability Initiative, which has been taken by the World Sustainability Council, and we have followed their principles. So we have followed 8 principles. One is the product design, product performance, raw materials, manufacturing process, waste management, life cycle, product stewardship, and innovations. So these are the 8 parameters on which we measure the performance of the concrete. Now for that purpose, I think what we are also trying to find out is how ecological or how user-friendly and how eco-friendly a product of the concrete is. For example, you use high STM concrete, that is whatever is permitted by the code, 35% replacement of fly ash and 70% replacement of GGBS. If anybody is doing more than that, and there are many cases, we are using high volume fly ash concrete, we are using plain concrete. Yesterday, Dr. Chatterjee himself showed that plain concrete volumes are so big that we can certainly use higher and higher percentage of SCM in that. So one who uses more than the code specified values get better marks there. Then aggregate. Aggregate, we are dead against the use of river sand, and we want people more and more to use a river, the manufactured sand, or what we call as a crushed stone aggregate or crushed gravel aggregate. And this is because I think very few people are aware that in recent time we have seen very serious failures because of unauthorized degradation of unauthorized extraction of river sand from big rivers. This is one example which we know, that a Savitri river in Mahad just collapsed during the floods. Nearby people were extracting, and this is one of the reasons why the bridge has collapsed, and many people have died here. Recently, I think we have a case of Vaitarna bridge, again from Maharashtra. I come from Maharashtra, so I have many cases of Maharashtra, where people were extracting sand from here, and ultimately the bridge has gone into such a serious situation that the well foundation has been cracked totally, and they have to, renew it. So I think it is important for our community today that we should take a pledge that we will not touch our rivers. We want river to flow in their own fashion. So why not, take a pledge that we will not allow the use of river sand. Second important thing is a thermal insulation, sound insulation, and which can come. And there are many ways by which we can do. One is by using low density concrete, which can be used by foam or expanded polystyrene, or by using perlite. And here we can get many advantages. The simple thing that we can do is we change our, brickbat coba, which we use on building. Why can't we use, instead of brickbat coba, a similar layer of, thermal insulation of lightweight concrete? It will give you better impact. High strength concrete, as we already know that as we increase the strength, we can reduce the section sizes, and this is what is happening in Mumbai, that any tall building, we are using high strength, high performance concrete. By increasing the grade of the concrete from M40, you increase to M80, M90, and you reduce section as well as you reduce reinforcement. And people have now, most of the builders are adopting this. So, and ultimately it leads to the use of lower amount of concrete, and we save a lot of resources. Another example is self-compacting concrete, where we don't need any vibration, so there is no sound, and that is why it is more sustainable. Another example is pervious concrete. Unfortunately, in our country, we are not seeing any big moment to use pervious concrete, because it is one of the best solution, I would say, that it gives you in rainwater harvesting and improving the quality of the groundwater. So I think this has to come on a big way. And after, after one goes through this example, then we can actually measure over a period of years to get measures. So all these three conditions are essential.
Sir, you have 2 minutes.
Yes, last slide, I think. And this is the evaluation process, which has been, done by the Confederation of Indian Industry. And these are the advantages that use of such product, green certification, will help the producer as well as the end users in a big way, and ultimately it will lead to benefit to sustainable benefit. Now, I just give you this example from United States, where they have used this certification, and what they have found out that you can easily get 26 point out of, the minimum required is, I think, 56 point. So you can get 50% of the point, and this is the example from United States. So if you want a green certification, LEED rating certification, this is the way. I think you can use concrete in a more greener way to get maximum benefit, get gold rating or platinum rating. Thank you very much.
Thank you, Kulkarni sir.
Yes, thank you.
Most of the stalwarts are out to get into the, I will come and give you a bouquet.
Not necessary now.
We now have Dr. Ajit Sabnis, who is the next speaker. Ajit Sabnis has been the president of Association of Consulting Civil Engineers. He recently got his PhD with a gold medal, and he is the principal consultant, ASP-SDI. Ajit, better you would explain what is it. And he has been a publisher, experience in repairs and rehabilitation work. Of course, he did constructions also. Ajit, the stage is yours.
Thank you. Good evening, fellow members, fellow engineers, ladies and gentlemen, and my dear students. Because of these two important factors, global warming and climate change. What exactly the sustainability or sustainable development is not actually very new to India. Thousands of years back, we were practicing sustainability. We knew what sustainable development was, and we knew what sustainable society was. As time evolved, as science progressed, we all felt that we all Indians aspired to have a better lifestyle, and then we started following to have the Western kind of lifestyle which is there. And dear friends, please mark my words. These are not my words. These are actually the opening remarks in National Building Code of India 2016. So this is how we are going, and then we actually have seen lot of effects. Now, this sustainability actually, which started about 50 to 60 years back, when few scientists and engineers came together, they formed an association called Club of Rome. They started discussing and they started thinking, showing concern about the natural depletion of natural resources, and that is how the sustainability word started. And especially in the last 50, 60 years, we have spoken enough about sustainability. We have research, we have been talking about it, but dear friends, I think now it is actually the time for us to act. We have spoken enough of it. A lot of water has flown under the bridge, and we need to get up, and a lot of remedial measures have to be taken up. We as civil engineers, we as nation builders, we have done enough. Actually, we have taken a lot of challenges right head on. We have included them in the codes. We have revised the standards, and we have probably evolved some regulations too. But these are the two important critical factors from engineers' perspective. What exactly are these three important factors which are bothering us? One is the global warming, second one is actually the climate change, and third one is the natural resource depletion. We engineers are directly responsible for these special things. The global warming is, of course, increase in temperature, in the average temperature of the surface of the earth, mainly because of the human activities. The human development, there has been growth, all these human activities which are essentially for human comfort, built because of human comfort, for human comfort, will add to global warming. Second one is actually a climate change, which refers to actually long-term changes in our climate. We need to understand what is the difference between weather and the climate. And the climate change is probably one of the long-term effect. The third one is actually the natural resources depletion, which actually is the reason for unscrupulous use of non-renewable sources. In all these three cases, we as civil engineers have a greater role to play. Before we actually go on to today's topic, how do we actually really evaluate this? In terms of percentage, we engineers do not talk subjective. We need to quantify. And how do we quantify? I think that is the one which next few slides will take. I would like to draw your attention to the construction industry related impact. What is happening? All over the world, 40% of the global energy produced is consumed by construction industry. 42% of the global water and 50% of the global raw materials are consumed by the construction industry. 50% of the world air population, 42% of global greenhouse gas emissions, 50% of global water pollutions, 50% of global chlorofluorocarbons. All these things actually are mainly by the construction industry. Indian scenario is not very much behind this, maybe plus or minus 5%, but we are almost at it. It is just not that. Cumulative carbon dioxide emission as a greenhouse gas emission, India has so far, in the last 250 years, India has emitted almost about 40,000 million tons as against China, or 3.75 lakh million tons to USA. Now, what is happening is United States, India, the previous speaker showed you the chart that we are in third or fourth in position. But actually look at the irony. United States with 5% of the global population is responsible for 28% of carbon dioxide emission. China, for example, almost about 22% of global population is responsible for about 26% of greenhouse gas emission. India, almost with about 16 to 17% of global emission, is responsible only for 6.5% of global emission. Though we are third in this list or fourth in the list, actually we are fourth in the list. First is USA, second is China, third is all Europe put together, that's the European Union, and fourth comes India. Now with this, it looks a very happy situation at this point in time, but it is not so with the increasing population. We have exactly China as an example, how the growth impact has impacted. Now let us come to per capita emission. These data, India is 1.84 tons per year, as against China and USA, you have the figures, etc. Now, we also have, let us look at the few impacts on the second part of it. What exactly impact because of the climate change? We just saw what is the impact because of global warming. Look at the climate change part of it. We have habitat fragmentation, fossil fuel that is happening. Then we actually have ocean acidification, eutrophication, loss of biodiversity, etc. India is considered as one of the 12 mega diversified countries in the world. We approximately have about 1.3 lakh species, flora and fauna put together. Almost at this point in time, with the present global warming, with the present rate of increase in temperature, we have almost lost about 50 species that are available in India, and almost about another 50 species are endangered, including human beings. Now, there are two important phenomena, dear friends, which have not been considered by anybody. These two important phenomena which impose tremendous amount of effect. One is called the polar amplification. This polar amplification is actually the drying up of the ice in the poles. For example, in Iceland, in Greenland, and the ice sheets of the Antarctica, all these are melting. And this melting of ice, which actually, if it had not melted, would reflect enormous amount of solar radiation back into the atmosphere. But now, because it is melting, the lot of open land is available for absorption. This is called polar amplification. Another important phenomena is called the permafrost phenomena, wherein the land, or with the trees, the bush, with the greenery, gets actually submerged in the ice. This may be applicable even to Himalayan mountain region. When the plants die below the ice, actually the carbon which is inhaled by those trees, by those plants, by the greenery, it gets remained in that. And once the plants die because of the ice cap which on top of it, once this ice melts, there's a huge amount of carbon dioxide released from these dead plants. This phenomena is called the permafrost phenomena, which is one of the most. These two important phenomena have not been considered by anybody while calculating the green effect or the sustainability aspect of point. Now we also come to, there are about 12 important indicators. They're called actually the global indicators or the tipping points. This is actually called the planetary boundaries or the eco-indicators, where these 12 important eco-indicators are brought together just to give us what exactly is the tipping point. We are all concerned here, dear friends. Please don't say that civil engineers are not related to this. We are the nation builders, and every aspect of it comes to our shoulders. For example, these the yellow bands, what we have seen actually is the points where we have already tipped off.